I'm happy to introduce the next speaker, Tong Wang, our Tom. She is assistant professor of marketing here at Yale School of Management. Her background is computer science. She got a PhD of computer science from MIT. So, as you hear, AI is becoming more and more important in marketing. The intersection between computer science and marketing is super relevant. So, she's been working on the LLM, Gen AI, the business application of those kind of techniques. And today she's going to talk about how we can use Gen AI for the content generation. Please welcome.
Thank you for the introduction. Hello, everyone. It's my great pleasure to be here. I'm Tong, and I'm assistant professor at the Yale School of Marketing, Yale School of Management in the quantum marketing group. And today I'm going to talk about a problem that has becoming increasingly relevant as firms adopt AI for content generation. So I'll show you a common problem with just blindly apply some fancy technique from CS to fine-tune your models. And then they will propose a solution to solve this problem, to mitigate this problem. And this is joint work with two of our wonderful co-authors. Professor Sudir is also a professor of marketing at Yale, and Tong Wang, he's a pre-doc, and he will join Columbia as a PhD student. Okay, let's start with the problem. So the particular type of problem I'm going to talk about is called creating hooks, which means the piece of content that the merchants use to increase engagement, to attract further actions from the users. For example, you can think of titles and headlines for articles, you attract people to click, or subject headlines or subject lines for email to attract people to click the emails. And including images like book covers or trailers for movies. Right? These particular content needs to be very engaging, very attractive, such that you're interested enough to enable some further actions. And in particular, we focus on use headlines because we have data from very clean, very measurable settings where we have A/B testing results. So if we want to use AI to automate this generation of this, it actually has been adopted by many firms. How we do that? So the simplest thing you can do is by prompting. You can simply tell AI what you want. You can say, write a catchy or engaging headline for this article. And it works fine. It gives you decent, reasonable performance, but it's not somehow optimized. Because if you just apply some off-the-shelf AI model, that model is a generalist because it has been pre-trained on the internet data. It knows a lot of stuff, but it's not specialized in the particular task. So it doesn't know how to generate headline or these hooks that are tailored to your platform, your audience, and so on. So how do we mitigate this gap? A practice that is being adopted by the industry is doing something we call fine-tuning, which is you give your private company's data that contains some user engagement and use that to train a model. You basically, for example, you give LLM many different pairs of good content and bad content, and tell LLM specifically, try to produce more like these winners and less like the losers. And somehow, this is a training what happens through, for example, some fancy techniques like RLHF, like reinforcement learning from human feedback, or DPO, these fancy techniques. We'll try to go back to change the parameters of the model to nudge the behavior of the LLM such that LLM will produce more like the good content you show them and less like the bad content you show them. Right? This is a very standard practice. So here's an example. If we just use one of the SOTA method, the state-of-the-art fine-tuning method to fine-tune an LLM. And for this article, it talks about, you can see this, I give you some sentences. Talk about like in Florida, they pass some policies and some discussions of the legal issues. And then the original headline is here. It says they made a mistake when they were kids, and now will never get to vote about the job thing. This is the original headline written by the human. Okay? And this is what AI generated. AI say this is shocking truth about one teenage girl in Florida that no one should ever know. Okay? So in this process, after fine-tuning, AI somehow identifies if I mention certain things, mention certain keywords like shocking truths, no one should ever know, somehow the click-through rate will increase. Okay? And this is not just one-off example. So we did a systematic examination of all the headlines generated by the AI on this batch of articles. We found that they significantly increases the usage of certain words and phrases. So for example, this is the percentage of headlines that use this phrase increased to more than 50%. More than half of the headlines will say, this is. Okay? And then more than 40% of headlines will say, shocking, and then choose. So usually, its headline will start with, this is shocking, choose about something. And this is because during this fine-tuning process, you give examples, and LM trying to figure out what makes certain headline better than the others. So it's very easy to latch on some vocabulary, but not a principle, because you don't tell LM, right, why it is better. You just tell them what works, okay? And let me give you more context by, the reason is that the data is actually silent on why something is better than the others. So the model tried to fill in the blank. And the model tried to fill in the blank by finding the shortcut. The easiest shortcut is to picking up some words and phrases, because that's the easiest to imitate. Okay? So let me show you the context and data set that we use for this experiment. We actually got the data from Upworthy, because this is a public data set. So in 2013 and 2015, Upworthy conducted this very large-scale A/B testing. So during each test, for each article, they published multiple versions of headlines, and then they record their click-through rate. So this is a very clean test where you know certain headlines work better than the others. And then we fine-tune on this. We show LM all these pairs of examples, some better, some worse. And this is what we found. In addition to this increasing use of certain words, we found that the language of the clickbait language increased twice, right? Like 100%. And then there are 5 times increase of the hyperbolic words like stunning, catastrophic, explosive, and so on. And also we found there's a very sharp decrease in the vocabulary diversity, meaning that the AI will try to repeat some of the phrases and the words. There's a this very large loss of diversity compared to original human-written headlines. Okay. All right, so what do we propose to solve this? How do we solve it? Now, the fundamental problem is that we show the AI what works instead of also telling it why. So here we want to also supply this knowledge. We tell AI the mechanism or the principle driving this engagement difference. And hopefully that can help AI to do better. But the challenge is that where does the AI, this why knowledge come from? Okay? So there are different options. For example, you can simply ask your human experts, right? You have human editors. You can ask your human editors to create guidelines. For example, they can say, oh, be specific, use strong verb, create urgency. This is more like a guideline of instructing AI. So AI sees not just the training data of the previous examples, but also some guidelines. Okay? This is one option. Another option is that you can actually also ask LLM to think about it, right? LLM can do this reasoning, can do the reflection. You ask LLM to look at the data and say, create a knowledge block or guideline. Okay, this is option B. Another option is something we propose, is that we will first use LLM to propose hypothesis. And then we'll do hypothesis testing and then validate on the data to filter out some of the not so useful hypotheses and provide a very short list of really useful principles and use that to guide our model. Okay, and then we'll compare with option A and B to see how we perform. So here is the process. In the stage 1, we'll provide many mini batches of headline pairs to the AI and ask AI, why did it win? Why did the winners perform better? And ask the LLM to propose hypothesis explaining, by drawing from their pre-training knowledge of explaining why something is better than the others. This is called abduction because LLM will try to come up with the best possible explanation given the observed outcome. Okay? Now, of course, during this process, LLM can generate many different hypotheses, right? Because we certainly supply many different batches of headline pairs, then not all of them would be correct. Of course, there are some hypotheses may only apply to certain small groups that are not generalizable, so that's why we need a second stage where we want to validate. So how do we validate? Now here the validation is that we want to eventually select hypotheses that are helpful in generating headlines. So during the validation, we will put the proposed knowledge block, which is a set of hypotheses, put in the prompt, and ask LM to generate headlines following this knowledge block. So the logic is, if following whatever the hypothesis we insert in the prompt, if that indeed improves the overall click-through rate or improves the performance, that means the knowledge is helpful. So we use the quality of generated headline to represent the quality of the knowledge. Okay? And then we iterate this process because every time we propose some change to the knowledge block by inserting some new hypothesis or throwing away some hypothesis, right? This is the iterative optimization approach. Okay. Right, now you might ask, all right, you are using AI to look at the data and propose hypothesis. Why doesn't that give you the shortcut again? Right? Because remember the motivation for doing this is I said that if you basically just train AI, fine-tune the LLM on the data, LLM will pick up the shortcuts. It will latch on some surface level patterns. Then if you ask LLM to propose hypothesis, how come LLM does not give you a hypothesis like you should use shocking, right? So our design is that we do not let LLM to see all data. We intentionally provide a very small batch of data, like 20 pairs, which is less than 0.1% of all data. If you do not show LLM all data, then what can LLM do? It has to fall back on its pre-training knowledge, right? That's obtained from broad training from internet data. Meaning that I don't give you all the evidence, I give you some cues. I force you to think deeper. Because of the lack of data, you have to think about the deeper mechanism. How am I supposed to explain this few examples, right? That's fundamentally how we prevent LLM from latching onto the spurious correlations. So let me give you some examples. And on the right is the LLM's hypothesis, trying to explaining why this particular headline is better than the other. This one is taken from the A/B testing where we know this one has higher click-through rate than this one. All right, and the LLM's explanations are, he lists some hypotheses. It says, leave a deliberate information gap that promise a dramatic reveal or anchor on one vivid scenario instead of scattering attention across many, and so on, right? So this is inspiring LLM to think based on this particular example. And as I said, we gather many of them, and then we solve a optimization problem to select the best set. All right, so this is a subset, and the LLM ends up selecting over 10 different hypotheses. This is a subset of them. So you can take a look. So the final hypotheses are, like the selected, validated hypotheses are like be specific and concrete, highlight personal transformation, create a sense of urgency, use intriguing language, use humor and playfulness, utilize conversational tone, and so on. Okay? And these act as some kind of guidelines. Now, the benefit of this is that once you train, this becomes a very general principle guiding knowledge that you can always insert in your prompt when you do this headline generation for your platform. All right, so how does it perform? Now here, this on the right is our method. And on the y-axis is the predicted click-through rate, because we didn't, this is from 10 years ago, this experiment, so we didn't have the access to run it again. So we train an AI model to predict click-through rate. And this gives you a score between 0 and 1, and this is a probability that the predicted headline is better than the original, okay? And the original headline, human headline is here, 31.5%. And if you do prompting without fine-tuning, you get actually even worse than the original human-written headlines. And this is the SODA method. It's called direct preference fine-tuning. It's the SODA method for fine-tuning. and it gets you very high click-through rate. Then I'll break it down to explaining why is that. And our method is adding this knowledge block is on top of the original soda, we're able to further improve the click-through rate, this scoring by 3.4%. Okay. And remember, our goal here is that we're adding this guideline as some kind of constraint. So the fact that we're not losing to the DPO, to the original soda, is already good news. Now let's see whether it mitigates the unintended behavior of using click-through, clickbait, or hyperbolic. Okay, so the light blue is a soda, and the gray is the original human-written headlines. And this is a percentage of hyperbolic language in the headlines. And this is a percentage of clickbait phrases. And this is a vocabulary concentration. For all of them, the lower, the better. So if you look at the middle, if you just directly use off-the-shelf soda method to do fine-tuning, you will significantly increase the hyperbolic language, clickbait language, and lose the diversity. Okay? If we use knowledge to somehow regularize or guide this fine-tuning behavior, you see we mitigate it significantly, in addition to achieving the 3.4% of increase. Okay? All right, and then we did some human evaluation. Even though we cannot do like a real field experiment on their platform, we recruit human to compare across the original and naive fine-tuning or using ours. Okay, and if they are tied, that will be 33%. But overall, out of the 100 questions with 143 participants, we're able to achieve 38% of click-through, compared to 31.5% if we use naive fine-tuning, and 30.5% versus the original. So there's indeed effective improvement in the engagement. Okay. And then in addition to that, we compare with the option. Remember, I promised you, I will compare with the option A, where we just ask a human editor to write the guidelines. Or we directly ask LLM to do some reasoning and then create a set of baselines, the guidelines. And then we compare with them. So if we use human knowledge or a very generic AI knowledge, so it barely lifts the performance and doesn't fix the side effect compared to ours. Okay? So the reason is because if you just ask human or LLM to write the knowledge, it is not grounded on the data. So neither the human or the AI, generative AI, has a nuanced and deeper understanding of what exactly the audience would like to see given this type of the platform or the articles. And our method is based on proposed by the data and validated by the data. So another thing we tried is, okay, since I've been complaining about the unintended behavior, which is overuses of the clickbait languages and the hyperbolic, what if we just directly penalize it, right? What if in addition to, say, optimize for the content, we also include in the objective function when you do the fine-tuning, say, now if you use clickbait, I'm going to give you a penalty, okay? That's another very natural way to do it. And turns out we find that if we penalize using clickbait, the click-through rate will drop by 37.3%. Okay? This is because you're just telling LM, don't do this, without telling him, oh, there's actually an alternative. You're blocking some way without telling him there's some other way to do it. Okay? So the performance will drop. Now, in addition to that, not just performance will drop, you actually didn't fix the side effects. Yes, your clickbait is fixed, because this is directly what you penalize the AI from doing. But AI somehow finds an escape from that, right? Instead of relying more on clickbait, AI now, the LM now will rely more on hyperbolic language. Okay? It's like you're blocking one way, and then they'll find another way to escape. Okay? So basically, you're playing as a cop chasing a thief or something. Okay? So therefore, we propose that the better way of regularizing or guiding LLM during this internalizing the observed data is not to penalize some behavior, but instead providing this data-grounded, validated guidelines or principles, teaching AI, okay, this is the mechanism you should follow to while learning this material, where the material is the observed experiments outcome from the A/B testing. Another test we do is that we wonder when this method or this knowledge will be more useful, because A/B testing data is actually very expensive to collect. It takes money and it takes time and resources, okay? So you can see on the x-axis, we vary the amount of A/B testing data. On the y-axis, and that's the performance we care about. The light blue is you just do blind fine-tuning. The darker blue is using knowledge. So you see there's a gap. And this gap is due to the gain of knowledge, right? And why is that? Because essentially, where did the LLM get the knowledge? LLM get the knowledge not just from your immediate data you have, right? We rely LLM on the reasoning. The LLM has to use the knowledge from the prior training, right? It actually seen lots of data. Then that knowledge somehow mitigates the less data here. So that's why you see a bigger gain. And this method is not just about headline, although I've been talking about headline, but it concerns a lot of the content generation problem involving like email subject lines. You think about push notifications, ad copies, product descriptions, whatever some content with some customer engagement metric you want to optimize. So when you try to optimize that particular engagement, you need to think about, there's some unintended behavior could happen due to blindly use the naive fine-tuning. So what we propose is that you want to use, try our model where you apply all your data to propose hypothesis, validate it, and include it in your fine-tuning pipeline. That can effectively give you a real performance gain while mitigating a lot of the unintended behaviors. Okay, so 4 things. First is that if you directly fine-tune on outcomes, that is not enough because the process is silent on the knowledge LLM should learn, but you didn't tell him. And the other thing is that, so we have to tell AI why certain things work better than the others, in addition to what. And the why has to be learned. But of course, if you do not have the resources to this massive learning, you can start with asking your AI agent, your human expert to write something. That still helps. It's just you will leave some gap on the table. Okay, but that's a good start point. And the last point is that it pays off most when your data is sparse. Okay, yeah, thank you. More questions?
Can I ask one? Sorry, this might be too technical, but would it be fair to characterize your knowledge-based approach as a semantic way to regularize?
Yes. It's a way of realization, just like the regularizer in machine learning. Yeah.
Got it, thank you.
John, what about I was talking to a company and he says, the more complex you make certain commands in the LLM, the hallucination rate increases. So even if you have average, high accuracy, one of the 1% headlines that are crazy and the risk mitigation, it causes, once it's automated, it causes high level of risk. How do you think about that?
Yeah, so in order to deploy this, before deploying this AI, there are actually some guardrails. You have to check, for example, not just like catchiness, maybe even like the relevance to the original article or the safetiness or some other metrics. Yeah, that it has to be in place before you run the AI.
Great. All right. Thank you.
Thank you.